Alright, this is your Unit 9 logs review video. I've just gone through and picked a few problems. Tried to get a variety. Okay. So back up to the beginning here. The expression log x to the x plus 2 minus log 10 of x is equivalent to what? So one thing I'll do in this problem is expand this a little bit. Anytime you have an exponent on a log, you can bring it to the coefficient location. So I'll rewrite this as the quantity x plus 2 times log of 10 minus x log of 10. Okay, now the base of a common log is 10, so there's an imaginary 10 hidden in there. So let's evaluate each of those logs then. 10 to what power gives you 10? That's 1. Okay, 10 to what power gives you, oops, this should be a 10. 10 to what power gives you 10? 1. So this is then x times 1, and then this is x plus 2 times 1. Okay, so really when I simplify here, I have x plus 2 minus x. My x's are going to drop out, so I'm left with just 2. And that's why that's B. Alright, for number 2, I'm going to just do A, where I'm going to, well, I'll do A and B, where I'm going to expand this so that it's of the form log 2 and log of 11. So first thing you may want to do is think about this as log of 2/11 raised to the 1/3 power. So the cube root is the same thing as the 1/3. I'll then take this exponent and move it out in front. So this is 1/3 times log of 2 divided by 11. Now what you need to remember is that division is related to subtraction. So this can be even further rewritten as 1/3 times the log of 2 minus the log of 11. So again, division is related to subtraction. Okay, so there's my log of 2, there's my log of 11, so this is 1/3. Log of 2 is equal to x, and log of 11 is equal to y. So that's one way of writing it, or 1/3 x minus 1/3 y. Now for B, which I'll draw a little line here so we keep it all separate, I got to rewrite log of 44. I can think of factors of 44 of 4 and 11. So log of 4 plus log of 11 is the same thing as log of 44. Because when you add logs with the same base, you multiply their arguments to combine them. Now, log of 11 is y, so that's great. So I have one part that I can write as y. However, log of 4 is not quite log of 2. But what I got to think of is I can rewrite 4 as 2 squared, and then bring that 2 out in front. So what I really have here is 2 log of 2, which log of 2 is x. So 2x plus y. Okay, so then I picked a couple types of solving problems. This first type, I have a couple logs on one side. What I'm going to do is combine these to one log. So I can get one log equals some number. Now since the logs have the same base of x plus 3, I can combine them using multiplication. So log base x plus 3 of, and I'm going to multiply 2x plus 3 by x plus 5. So I've got 2x squared, 10x, 3x, and 15 is equal to 2. Okay, so now that I have the log, what I can do is lasso this to get rid of the log. So I can take the base, lasso the exponent. Okay, so this is going to be x plus 3 to the second power is equal to this whole mess, but I'm just going to clean it up a little bit. So 2x squared plus 13x plus 15. Okay, now x plus 3 squared is not x squared plus 9, it's x squared plus 6x plus 9. Okay, so I'll set this equal to 0. So x squared plus 7x plus 6, and then I'll factor that. So x plus 6, x plus 1. Factors of 6, that's 7 to 11. So x equals negative 6, and x equals positive 1. Okay, so if I go, or negative 1, excuse me. If I go back to my original, so that's this line right here, I just got to check. My argument, meaning this stuff right in here, can't be negative. And additionally, the base can't be negative. So if I look at negative 6, and I plug negative 6 in, not only is that going to cause the arguments to be negative, it's going to cause the bases to be negative. So that's out. X equals negative 1, we'll keep this positive, keep that positive, and it keeps the bases positive. So therefore, x equals negative 1 is my answer. I didn't say I was going to do it, but I will do I here. I'll just add this to my list. If I want to solve for x, we isolate the exponent. So equals 5. And then I take the log of both sides. So x log of 3 is equal to log of 5. And then to solve for x, I just have to divide by log of 3. So this is where you'd go on your calculator. Turn on. Alright, and I do log of 5. Make sure you close your parentheses. Divided by log of 3. Okay, so it says 4 decimals, so 1.4649, so that means this goes to 50. Okay, so now I'm going to do number 11. I have multiple logs, and they all have the same base, so I'm going to see what I can combine. Subtraction is related to division, so I can write this as log of 4x plus 16 over 2 is equal to log of 3x plus 5. Now the log bases are the same. I can drop the logs. So now I'm just solving 4x plus 16 over 2 is equal to 3x plus 5. So 4x plus 16 over 2 is 2x plus 8. So if I subtract x and subtract 5, I get 3 is equal to x. Alright, inverses. Don't forget that logs and exponentials are inverses of each other. So if you're going to find the inverse of a log function, you're going to end up with an exponential function. If you find the inverse of an exponential function, you're going to end with a log function. So this first problem over here, b, I have a log, so I should end up with an exponential function. First step is to switch x and y. Okay, I'll do 4 to the x is equal to y minus 7. Now the only thing I have to do to isolate the y is add over the 7. So y is equal to 4 to the x plus 7. Now I'm not going to leave it as y though. I'm going to write this as f inverse of x. Okay, and like I said, I ended up with an exponential, which was exactly what I was anticipating. Okay, now at letter C, again we switch x and y. Isolate the exponential. So x minus 3 is equal to 5 to the y. Now I'm going to rewrite this in terms of a log. The base is going to stay in the base. So log base 5. Now you got to think it's got to be 5 to the y, so this must equal y of x minus 3. 5 to the y equals x minus 3, so that makes sense. Now I won't leave it as y, I'll leave it as y inverse. And then that'll be our inverse. Alright, word problems. Don't forget to know your formulas. A equals P e to the RT, and A equals P times 1 plus R over N to the NT. So this is your continuous formula. This is compounding quarterly, monthly, whatever. So Anthony deposits $1,400 into a bank account. He wants the money to grow to $2,000 to make a deposit on a car. How long, to the nearest tenth of a year, will it take for the money to grow to $2,000 with no additional deposits or withdrawals if the bank offers interest compounded quarterly at 5.2%? So that means we're going to use this formula right here. Okay, we want his amount to be $2,000, and he's putting $1,400 in the bank. Okay, R is 0.052. N is going to be 4 because you're compounding quarterly, so 4 times per year. The only thing we don't know is T, so this is what we're going to be solving for. Okay, so I'm just going to clean this up a little bit. So what I can do is take 2,000 and divide that by 1,400. Come on. Okay, and I don't feel like dealing with decimals, so I'm just going to convert this to a fraction. So 10/7. Now 1 plus 0.052 divided by 4 will give me 1.013, so I just simplified this, raised to the 4t. Now t is in the exponent, which obviously I don't like, so I want to bring it down to a better location for me to solve for it. So I'm going to take the log of both sides, and that's going to bring this exponent of 4t out in front. So this is log of 10/7 is equal to 4t times the log of 1.013. Now remember, you're solving for t, so I don't care about the rest of the stuff over here. So I'm going to divide out everything I don't want. So 4 log of 1.013, whatever I do to one side, I do to the other. Okay, now what's really important here is when you type this in your calculator, you use parentheses. Otherwise, you're going to get the wrong answer. Okay, so to the nearest tenth, 6.9 years. All right, Newton's law of cooling problem. A pot of tea is heated to 90 degrees Celsius. Oops, that's like super dark, I don't like that. 90 degrees Celsius. And a cup of tea is poured into a mug, which is taken outside where the temperature is 18 degrees Celsius. After 2 minutes, the temperature of the cup of tea is approximately 65 degrees. Here's Newton's law of cooling. They tell you everything. I want to determine K to the nearest 4 digits. So first of all, the temperature surrounding the object, that's just like outside. So that's the outside temp. So according to my problem, it's 18 degrees outside. The initial temperature of the object, they tell me, is 90 degrees. After 2 minutes, so after these 2 minutes, the temperature of the object is 65 degrees Celsius. Okay, I want to find K. That's the only thing I don't have. So I'm going to plug all this information into this formula. So again, T is 65, T of A is 18, T of 0 is 90, T of A is 18, E to the negative K and t is 2. Or little t is 2. Okay, so now we just got to clean this up a little bit. So I'll subtract the 18, which will give me 47. And 90 minus 18 is 72. Okay, at this point, I'm going to divide everything by 72. Okay, so 47 divided by 72, don't feel like dealing with decimals, is equal to e to the negative 2k. So in order to get to this k, I got to bring it down to the coefficient. I'm going to take the natural log of both sides, because the natural log, or the base of a natural log is e, and that'll create an ln of e, and that's 1, and it'll be all nice and good. So the natural log of 47 divided by 72 is equal to the negative 2k natural log of e. So like I said, the natural log of e is 1, because it's like saying log base e of e is what? Well, e to what power gives you e? Well, that's just 1. And so that works for anything when the base matches the argument. Okay, so ln of e is 1, so it's like multiplying by 1, so it's pretty much irrelevant here. So all I have to do now is divide everything by negative 2. And then that's when I go to my calculator. Okay, so what did it say? 4 digits, 2133, excuse me. So 0.2133. Okay, so determine at what time the t will be 52 degrees to the nearest tenth of a minute. Okay, so now we know the decay constant. So what I'm going to do is take 52 degrees Celsius, and that's going to be my new capital T. So temperature after however many minutes, and that's little t. Okay, so subtract 18, so I get 34. And then divide by 72. I'll take the natural log of both sides because of that base of e. And then, like I said before, the natural log of e is 1, so I can ignore that there. So my last thing I have to do is divide everything by negative 0.2133, and that will have me solve for t. Okay, so about 3.5 minutes. So what's nice about really all these problems is don't forget that you can check them. So like at part B, what you could do is take the 3.5 and plug it back in for t. I might even do the unrounded answer because it'll be more exact. Plug that back in for t and see, do you get 52? So let's just even do that, just to remind yourself, because you can do a check. Okay, so is 18 plus 72 times e to the negative 0.2133 times, I'll go grab that number, 3.5 number. Oops, nope, I guess it won't let me grab it. All right, so 3.51776071. Okay, so just double checking here. All right, so if I hit enter here, because all I did was plug in about 3.5, you know, the unrounded answer, and for t I should get 52. Whoa. All right, so I did. So that worked out. So yay. All right, so we did it right. So 3.5 is the answer. All right, next, number 11. Mandy purchased a $28,000 $28,500, or sorry, she paid $28,500 for a Chevy Equinox. She wants to sell the car when its value is 30% of the purchase price. If the car is appreciating at a rate of 16.5% per year, in what year should she sell her car? So we're talking depreciation. So this is our formula. It's just decreasing. Okay, so what I could do here is figure out what 30% of that is. So 0.3 times that would tell me what A would end up being. So let's see, 0.3 times 28500 would give me 8550. The rate is going to be 0.165 to represent 16.5%, and then I'm solving for t. Now what's going to happen when you divide both sides by the 28500 is you're going to get 0.3 in for A. So you even could just plug 0.3 in there, because that's just going to be 30%, so that makes sense. Times 1 minus 0.165 is 0.835. Okay, you have to bring the t down to a more desirable location, so we'll take the log of both sides. Alright, so then the last thing I have to do is divide by log of 0.835. And then I'm done. And to the nearest, well, actually wait, so t will end up being like 6.67 something, whatever, but it's asking me in what year should she sell her car. Keep in mind she bought it in 2011, so 2011 plus, you know, an additional 6 and some change years is going to give you 2017. So I guess this year she should start looking at selling her car. Okay, graphing logs. So one thing I want to remind you of is if you have a log, there's an asymptote. So before even plugging this in my calculator, I know this graph has been shifted down 4, and it had also been shifted to the left 2 units. Now the asymptote of a natural log, or just any log function, is normally at the y-axis. But since I moved to the left 2 units, the asymptote's also moving. So I'll even just draw in this asymptote to remind me that it's there, so that I don't cross it, and I know just to approach it. So at x equals -2, there is an asymptote. Okay? So if you want to get a table of values for this, you have to use change of base to plug it into your y equals. You're going to do log of x plus 2 divided by log of 3. So log of the argument over log of the base, and then -4. So let's do that. And I'll just show you a graph. Okay, so there's your log. I told you guys in class that this tail is going to just disappear. I need to make sure you understand that this continues because it's approaching an asymptote that's right here. So if you look at my table of values, if I go back, eventually it says error. That doesn't mean that the first part of the function is just -1,4. There are other points. Their x values are just in between -1 and -2. So please, 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 please remember that tomorrow, that this is not the start point. It's just it's like the last good point that the calculator has to give you. So if I do my table of values, I'm just going to pick out some good points. So like -1, -4, 1, -3, and then, whoops, where'd it go? And 7, -2. So just write down your table. Okay, and then plot these points. Now, like I was saying, this is usually where people stop, and you cannot do that. Just because this is the last good point you have doesn't mean that this is the graph. That's not a log function, Remember, logs are inverses of exponentials that look something like that. So it doesn't make sense for it just to stop right there. So that means you need to take this and extend it toward the asymptote and not crossing it. Okay, now according to my directions, it wants me to label it. So I'll call this log base 3 of x plus 2 minus 4, and that was f of x. Okay, so it's graphed, it's labeled. So the domain of this function, if you look from left to right, we have a restriction. You're not going to pass x equals negative 2. So your domain is going to be from negative 2 to infinity. And your rails, your range, if you look up and down, this is going to keep going up, and this is going to keep going down. So your range is all reals. Okay, putting something into standard form. This basically just means, or general form, this just means you're going to expand it and simplify. So if you look at B, I know that division is related to subtraction. So I can write this as log base 2 of x squared minus log base 2 of 32. Any coefficient you can move to, or any exponent you can move to the coefficient location. So this is then 2 log base 2 of x minus log base 2 of 32. And then you just need to simplify. So 2 to what power gives you 32? That's 5. And then 2 log base 2 of x. That's in general form. So the transformations that took place were a vertical stretch of 2 down 5. Alright, one last problem. We're going to do half-life. So this is your half-life formula. Okay, where this is your initial amount, t is time, and h is the half-life, and a is what you end up with after that amount of time. This b value is always going to be 1/2 because it's a half-life problem. You're multiplying by 1/2 every so many half-lives, or however much time a half-life is. Okay, so this needs to be memorized. Radioactive isotope of sodium-24 is used as a tracer to measure the rate of flow in an artery or vein. The half-life of sodium-24 is 14.9 hours. Suppose that a hospital buys 40 grams sample of the sodium-24 and will reorder when the sample is reduced to 3 grams. Okay, I'm actually going to go just to part B because part A is just plugging in stuff. Part B says, how much time will they need in order to reorder the new sample? So they said they're going to reorder at 3 grams, right? So that's going to be A. A sub 0 is what we started with. That was the 40 grams. Okay, we don't know how much time is going to pass. That's what we're trying to find out. But I do know the half-life is 14.9 hours. Okay, so round to the nearest hundredth of an hour. So here we go. All right, so I'm going to divide by 40. So 3 divided by 40 is 0.075. Okay, and then I'm going to take the log of both sides. Okay, so what I may do on the right-hand side is just simplify this. Okay, keeps turning off on me. Okay, so log of 1/2 divided by 14.9 is just a number. Okay, so I have log of 0.075 equal to this number essentially times t. Over 0.0202 blah blah blah. Okay, so if I want to solve for t, I just have to divide both sides by that negative 0.0202 number. So in my calculator, I'm going to do log of 0.075 and divide that by said number. Okay, so second answer. There we go. So to the nearest hundredth of an hour, 55.68. So again, this is something that you can check. So I can take that 55.68 number and plug it back in and say, do I get 3? So 40 times 0.5 raised to the, what was it again? 55.68. Oops, parentheses, 55.68 divided by 14.9. I should get approximately 3. And I do. Okay, obviously I rounded it so it wasn't exact, but that's a way that you can check your answers. So just don't forget that that's an option for you. All right, so if you have any questions about maybe material from the part A of this, since it was before a midterm break, Miss Costanzo has a video on that. So you actually have 2 videos for this unit, so that's kind of nice. Happy studying. Good luck.